Hello everybody, this is going to be a very boring video, and if you want to see the result, just skip all the way to the end and the last minute or so, then you'll see the result. And I'm doing a little test on a G8 power supply and a P720 phonostage. This G8 power supply has a total of 9 Farads of capacitance inside, and I need to prove it to my customer. It will play longer than 5 minutes without AC power, and it's turned out it can play up to 10 minutes or more. I am putting a signal through the signal generator and going to signal generator wire. One piece is this is the output from the signal generator to the input of a P720. I'm driving one channel only, but since it's a line stage, it's not going to make much difference on current draw. And this is the output. I can show the back. Output. This is the output. This is the input. Input, output, and this is just a loading plug for the other channel. And this is the output back to here, all the way back to the signal generator. Currently, I have a 0.585 or 586 volt of output showing on the scope. And this is 1 kilohertz single sine wave only. Again, because this is a line stage component, it's not going to make that much different current draw, and I am confident that this can prove it will play more than 5 minutes. It doesn't matter how loud it plays. Again, it's a line level component. Okay, so this power cord's going down to this power bar down here, and I have a power switch on the power bar. What I will do is I will put it on this stand so I can show a stopwatch. Let's see, I got stopwatch right here, but I will have to start the stopwatch and turn on the power switch, turn off the power switch at the same time, and that will put it back here so you can actually see the stopwatch running sine wave. And when this 565 or 5.585 start to drop, that's the time that we have to call the end of the power supply draining. So okay, so I'm going to put the camera down so I can use both hands, one hand to start the stopwatch and the other hand to turn off the power switch. And then after I turn off the power switch, I will also unplug it from the AC, from this AC outlet, just to prove it I have totally cut off power. And let's see, this is a power, this is a stop. Okay, stop, start, stop. Okay, that's the start button, and power switch at the back down there. I am going to put it down. Let's see, put it down here. You just have to trust me on this one because you can't see me doing it. Okay, well, let me try this one. I can probably do it this way. Now, it's already 3.5 minutes. I told you it's going to be boring. You don't have to watch the whole thing. See, I can bend this down. Okay, stopwatch here. Yep, okay, I can start doing that. Power switch down there, stopwatch 3, 2, 1. And then you can see me. You can probably see me unplug this. Stopwatch is running. Unplug this. Okay, no more AC. And I'm gonna put the stopwatch back in here. I know the cell phone will probably go dim, and I have to come back and turn it back on once in a while. Now put it back on the stand. Put it back on the stand. The last time I run it would actually run more than 10 minutes. So if you want to skip it from here to the end, so you can scroll it all the way down to 14-15 minutes. The end of the video, I don't actually know how long it will run, but I just tested once. I know it will run more than 10 minutes. So let's zoom in a little bit so you can see the stopwatch more clearly. Yep, you can see the stopwatch now. Sine wave and stopwatch. Again, 586 sine wave. So when this number starts to drop, that's the timing we have to start calling a quit. And right now it's 1 minute 28 seconds. I can stay here and keep talking about some, well, things that doesn't make quite sense, but or I can just walk away and do something else and come back. And there's some background music, and I hope that YouTube's not going to call me a copyright things. Maybe I should shut it down too. Okay, I'm going to shut that down. I turned it down. I didn't shut the whole thing down because I'm doing testing over there too. Oh, it got dim already. Okay, so I can squeeze this in here. And 2 minutes 24 seconds. So at least 7 or 8 minutes to go. Some of you might think is playing the music on the turntable and see how long the music shut off. That might be a better proof. And there's a point there. Yes, you can actually say the music shut off. That's when its power supply is drained. But at the same time, high gain amps like this, when they start draining, it can make some noise. That's one thing. And second, if I use a single sine wave through one channel, I have a more reliable reference point, because saying, well, I'm playing this for this long. Now again, it's not going to make that much difference on a line stage component, but in terms of the power amp, playing the music louder will drain the power supply faster, and but not apply to line level component, because it doesn't make that much difference because of the high impedance and the low current draw from the power supply. But it is not so much about how much current it draws from the power supply that makes the sound different. This is analog, and analog is all gray area, is not black and white. It's how the energy being handled, how the energy being flow, how the energy being drawn, and it's also and there is no corrections in analog signals. Once it's gone out, it's out. We can't correct it. Unlike digital. It's gone dim again. I'm going to press his 4 minutes 29 seconds. It's still going, and I probably have another 5-6 minutes. I can make some noise, I can talk some more, but I'd rather not. But if I think about something, I can start talking. But it's the timing. The stopwatch is what you're watching. If you really want to watch it, you can keep watching. Otherwise, you just scroll to the back again. Just scroll to the back if you want to see the result. But if you want, the reason I need to do this, the whole thing, without stopping, without editing, is because I want to prove it to my customer. This is real. There is no tricks. It's completely real time. So if I say anything wrong, I just correct myself. So far, I don't think I said anything too far wrong. I don't need to edit, and I don't edit my video anyway. Well, I haven't yet edited my video for a long time because editing takes more time, so I'd rather spend the time to build more toys. Five and a half minutes. Yep, it's still real. I'm still here. Well, actually, if you look at the stopwatch, I can't fake the stopwatch, so it's a real time. It is a real time video. And I'm drinking my coffee. And my cat is meowing. gone dim again. It's past 10. The video past 10 minutes already. I'll probably still have another 4 or 5 minutes to go. Maybe I can find the cat and see I can put her on the camera. Let's see if we can put you on the camera. Wow. There. Oh, I blocked the stopwatch. That's not a trick. All right, get up. Ooh. What? Yeah? What? Wow. Hey, don't move the table. Ah, 9 minutes. Scan there. We're getting there. We should be shutting down soon, but probably past 10 minutes before it will start to shut down. Now dropping 1 millivolt, just not quite, but it's a small sign of draining closer to affecting the signal. But we definitely passed 5 minutes long time ago. Past 5 minutes ago. Okay, dropping 2 millivolt now, so we can basically call this a starting to shut down. But if you play music, it will still play. But it is reaching to the point that's starting to shut down. Yeah, it shut down. So that's the end of the video, and I know it's boring, but I need to do a proof, and instead of just putting the video, sending the whole video to the customer, I put it on YouTube so everybody can see it. Until next time, See you later. Bye.